Today on How It's Made Dream Cars, the Chevrolet Corvette Stingray, a legend reinvented. In 1981, General Motors moved its Chevrolet Corvette assembly plant to Bowling Green, Kentucky, which is also home to the National Corvette Museum. Here, a bust pays tribute to Zora Arkus Duntov, the man known as the father of the Corvette. The first Corvette design was led by General Motors head of design Harley Earl in 1953. Not long after, Zora Arkus Duntov saw that original car at a New York Motorama exhibition and fell in love with the Corvette look. By the 1960s, he helped create the famous Corvette Stingray, a stylish and powerful sports car. Chevrolet stopped using the Stingray name on Corvettes after 1976. But with the 7th generation of the Corvette, the Stingray rides again. It incorporates aluminum and carbon fiber materials, together with state-of-the-art powertrain technology. This car has been completely redesigned to create a fast, lightweight update to the automotive legend. Here, a robot positions components of the Stingray frame in a jig, known as a geometry setting tool. With the first component in place, a worker loads in a part called the seat back beam, followed by the seat back panels and the tunnel side panels. These are all part of a component simply called the tunnel. Once the setting tool has clamped everything firmly in place, the wall behind it pivots on its axis and swivels 180 degrees, revealing a recently welded tunnel. On the other side of that wall, a pair of robots begin welding the parts. Just 155 seconds later, the tunnel is welded and ready for the next step. A robot prepares the body length rails. A second robot loads the tunnel between the rails on the tooling fixture. The car body begins to take shape as the front and rear bumpers go on. All of the components are made of aluminum, which offers rust-free rigidity, lightness, and durability. Once all the components of the frame are clamped in place, a robot quickly welds the joints before the frame heads to the next station. By the time the Stingray is finished, it'll have roughly 350 resistant spot welds and about 70 laser welds. That's more than 36 feet of laser welds. While the frame is a vital element of the Corvette, the body panels create the Stingray's distinctive look. Here, a worker loads a set of panels onto a carrier. The carrier moves at a speed programmed to keep up with the pace of production. At the priming booth entrance, a reader scans the unique barcode located on each carrier and sends the information to a computer, which tells the robots what to do. In just 2.5 minutes, they prime the entire set of panels. The panels then head across the hall into a giant oven where they will bake for 30 minutes at a temperature of 260 degrees Fahrenheit. After that, the panels will receive a base coat in one of 10 different colors, followed by a clear coat. Finally, they arrive here, where a team of technicians inspect the surfaces and correct any defects with sanders and polishers. The paint shop also handles another process called sonic welding. Here, a worker positions the Corvette emblem in a fixture, then lays the car's fascia on top. He inserts composite brackets into the fascia. The fascia and the brackets, which are made of a material called thermoplastic polyolefin, or TPO, form the nose of the car. These brackets will provide locating points for the headlight installation. Once they're installed, the worker clamps them in place. A robotic arm begins the ultrasonic welding process. This means it uses high-frequency sound waves to melt the bracket onto the fascia at specified weld points. These sound waves are inaudible. There are 25 weld points for this part. The robot completes its task in just 3 minutes, perfectly bonding the brackets and the emblem to the panel. At the heart of every Corvette is a classic American V8 powerhouse. The Stingray's engine is 6.2 liters, 461 horsepower, and has a top speed of 190 miles per hour. The engines are made here at the GM Tonawanda Engine Plant in Buffalo, New York. They start with a precision sand-cast aluminum block. Here, a team of robots conducts a series of tests, including the water jacket leak test and blockage tests. A camera checks for the presence of all the necessary threaded holes that will provide attachment points during the assembly of the car at Bowling Green. A data bolt, which is an actual bolt that contains a computer chip, records the engine's progress as it moves through production at Tonawanda. Here, a worker prepares to install the crankshaft. He places a specialized guide in the block to prevent any damage to the crankcase as he lowers the pre-oiled crankshaft into position. These powdered metal piston rods are known as fractured rods. That's because the supplier actually breaks them at the point where they will encircle the crankshaft. The irregularity of the fracture surfaces allow the technicians at Tonawanda to realign the rods perfectly during installation. Now, a technician uses a device called a piston cup to compress the piston rings at a tapering angle. This makes it easier to slide the piston assembly into the cylinder. The second worker uses a blue tool called a guide fork to guide the rod in without damaging the piston liner or the crankshaft. This is the oil pan RTV station. RTV stands for room temperature vulcanization. With the bottom section of the oil pan clamped upside down, the machine squeezes a thin bead of RTV around its perimeter. A camera verifies that the orientation is correct. The machine flips the bottom section of the oil pan 180 degrees and brings the top section up to meet it. The turntable then swivels, delivering the next oil pan while allowing the worker to transfer the finished one onto an inverted engine block. This process must be accomplished quickly before the RTV has a chance to cure. 16 spindles descend to tighten the oil pan fasteners to the precise torque required. Here at the head sub-assembly station, this machine installs both exhaust and intake valves at the rate of 48 parts in just 40 seconds. One of the arms grabs a set of valve components, dips them in oil, and inserts them. The machine flips the head, then the second arm installs a series of springs, compressing them slightly and dropping a key down inside them. As the spring decompresses, the key locks, holding the spring in place. A technician positions a component called a cylinder head gasket on the engine before installing the head. This gasket is a high-tech multi-layer steel component that must seal in oil, coolant, and combustion. The cylinder heads integrate a fuel rail to accommodate the direct injection fuel system. 2 workers insert the 16 push rods that will transmit motion from the camshaft to the valves. Once the rods are in place, the workers install components called rocker arms. The motion of the camshaft will transfer through the push rods to the rocker arms and then to the valves. The workers have only partially screwed the rocker arms in place. At this station, a specialized device orients the engine so that no valves are open, before tightening the bolts to the necessary torque. This operation is called the rocker arm rundown. A technician installs the rocker cover and coil packs. The rocker cover seals the valve train, while the coil packs supply ignition energy to the spark plugs. A piece of foam sound insulation goes over the engine before a technician positions the high-density composite plastic intake manifold on top. Last but not least, a machine attaches the exhaust manifold together with its gasket. Made of cast stainless steel for strength and durability, the exhaust manifold features equal-length runners for optimal engine performance. From start to finish, the new Chevrolet Corvette Stingray will travel 7 miles on a network of conveyor systems as workers transform the components into a complete car over the course of 3.5 days. Since 1981, all Corvettes have been made here in Bowling Green, Kentucky at the Bowling Green Assembly Plant, which covers 1 million square feet. To build the car, workers rely on a special conveyor system known as a towveyor. This consists of tow carts which move at precisely timed speeds along tracks set in the floor. This allows workers to mount components on the chassis as it moves, ensuring smooth, timely assembly. Here, a worker uses a hoist to settle the transmission into its cradle, where they will secure it. The new Stingray comes with 2 transmission options, an 8-speed automatic transmission with paddle shifting, or a 7-speed manual transmission with active rev match. As the chassis moves along, the engine travels a parallel assembly line. The 2 lines meet at precisely the right time. Workers transfer the finished engine to the chassis and lower it into position. Workers now connect a long cylinder called a torque tube, which will transfer the engine's torque to the transmission. And of course, the transmission will be controlled from the Stingray's high-tech cockpit, which is ready for installation. All the joints get a protective coating of urethane before a robot lowers the cockpit onto the car frame. 32 bolts on each side secure it in position. At this station, a robot applies a urethane adhesive on a component called the wheelhouse as a cart docks a car in a precise location. Automated lifts install the wheelhouses on the car and hold them there for 90 seconds as the adhesive cures. A worker brings the left rear quarter panel to the car and attaches it with several screws on the top and several in the door frame. Next, she installs the fuel nozzle. With the new Corvette Stingray, you'll never accidentally leave your gas cap behind at the service station. That's because there is no gas cap. Thanks to a clever spring-loaded mechanism, the nozzle self-seals when you finish fueling up. Next, technicians use hoists to install the seats. There are 2 different seat options, the standard GT and the competition Sport. A protective ring around the perimeter of the door opening ensures this process won't damage the car body. A worker removes the backing from a self-adhesive Corvette emblem. He uses a jig to make sure the emblem is perfectly positioned before adhering it to the rear fascia of the car. While there, he also takes the opportunity to test the rear LED lights. He now rotates the panel to the upright position. Although the rear fascia is lightweight, Corvette mandates that 2 workers should walk the part to the car. This helps prevent damage being done to either the part or the car, as the workers carefully install it together. The powertrain and the car body have been assembled on two separate conveyor lines that are precisely timed to converge here. The overhead conveyor slowly lowers the body as the towveyor raises the powertrain to meet it. Once technicians have bolted the body and its powertrain together, workers install the hood, which is made of strong, lightweight carbon fiber. A technician then uses spacers or gap tools to make sure the gap between the hood and the rest of the car body is the correct width. After fastening the hood to the car at its attachment points, he double-checks the width with a set of gauges. Satisfied, he removes the gap tools. A worker now installs the headlights. The Corvette Stingray features amber LED turn signals, framing the bi-xenon frosted indirect HID high and low beam headlights. There are also white LED DRL under each projector. With the lights fully installed, two workers can now carry the front fender to the car and position it for installation. The fender includes the Stingray's distinctive grille and the Corvette's famous emblem. A technician uses a hoist to position the wheels for installation. The wheels feature Michelin Pilot Super Sport tires, specifically designed for the Stingray. A fully decked out 7th generation Corvette Stingray features magnetic selective ride control, head-up display, a 10-speaker audio system, and a drive remote selector with 5 different options. These Corvettes are completely assembled. An overhead conveyor system slowly lowers them until the wheels touch the ground for the first time. The car has a dry weight of 3,159 pounds. With all its fluids, the curb weight will be 3,302 pounds. Here, bright side lighting allows technicians to carefully inspect the car for any flaws in the paint job or the gaps between the body panels. A worker then starts the car up for the first time and drives it over a rumple strip to an alignment station. Here, technicians will use precision equipment to perfectly align the steering system and the headlights. In a pit under the alignment station, a worker carefully adjusts the wheels. The steering wheel must be no more than 5 millimeters off its center position when the wheels are pointed straight ahead. Simultaneously, an optical sensor moves back and forth in front of the car to gauge the position of the headlights. At a distance of 25 feet, the middle of the headlight beam can be no more than 5 millimeters off center. The car is now ready for the dynamic vehicle test. Here, a driver tries out every switch while revving the car up to 80 miles per hour as a computer runs over 800 tests in just 2 minutes. It checks everything from the engine cylinders to transmission shifting and emission levels. Once past the dynamic vehicle test, the car must endure a powerful simulated tropical storm. This is known as the water test. For 2 solid minutes, high-pressure jets hammer the car with 12 gallons per second. The driver uses a flashlight to examine the interior for any signs of leakage. Under such an intense barrage, the smallest crack will show up. The driver now takes the car over something called the squeak and rattle track, which simulates different road conditions. As he drives, he listens carefully for what else, squeaks and rattles. The new Stingray is the latest in a long line of famous Corvettes. In fact, Chevrolet has made more than 1.5 million of them in total. In production since 1953, the Corvette is the world's longest-running, continuously produced passenger car. The original 1960 Stingray took more than just its name from that hydrodynamic fish. The design of both the old and the new Corvette Stingray features smoothly curving transitions from surface to surface, enabling air to flow over and around it at high speed. This design feature, taken together with the new Stingray's powerful V8 engine, high-tech transmission, and lightweight construction, make it a true Corvette, paying tribute to a celebrated past while roaring into the future.